My name is Joel McKay. I'm the Director of Product Development here at Z1. Z1 is a one-stop shop for everything Nissan and Infinity. But predominantly what we do is related to vehicle performance. So air intake systems, exhaust systems, things related to engine cooling and charge air cooling, suspension and braking performance. When we develop performance products for these platforms, we do not get OEM CAD data from Nissan and Infinity, so we're not able to design based on information that they gave us. Instead, we have to reverse engineer the packaging envelope of these vehicles. To do so, we use scanners. So 3D scanning is at the beginning of almost every product that we develop. Now, with the ability to do it quicker, more efficiently, our designers are more willing to grab the scanner, go get the data they need, come back, look at it in SolidWorks, realize, oh, I want a little bit more, and they'll go scan some more. It's a much more efficient process than it used to be, and it causes our design product to be more accurate, which means that we get to market faster because we don't have as many revisions, and the end product for the consumer is improved.
We initially had the Space Spider, which has amazing detail, but for a lot of the parts we do, it's too fine, if you can believe that. It'll scan the dust in the air, but when we're trying to scan an entire car or entire engine bay, it's too fine. So the next one we got was the Leo. And as you know, you can patch the scans together. So you can scan an entire engine with the Leo and then come back with the Space Spider and tie the detail into it.
The Space Spider we had first, and it had proven to us to be able to do very good at small parts where we needed a higher level of precision. Where it did not have the capability was to be able to scan a large area quickly, and that's where the Leo comes in. So we added the Leo to the mix, and we use it for, I would say, 95% of our scanning at this point. Because with the Leo, we're able to scan a very large area accurately in a short amount of time.
I scanned the bottom of a Z in 4 minutes and used that to design an exhaust. If you can imagine designing exhaust before, you have the transmission crossmember to go around, you have the sway bar to go over, chassis bracing, exhaust tips to locate. Using the scan, I modeled the exhaust, 3D printed it, it fit, then had the sample, that fit. And it was 4 minutes of scanning, quickly imported the model, modeled the exhaust, and that was it. And it's a game changer. Before it would be fabricating a sample and then trying to reverse engineer that sample, fabricating a new sample. Yeah, completely changes their workflow. The Leo, it's fast. It's really fast. I would say I can get a useful scan of an engine bay in a couple minutes, an entire engine in 10 minutes. A recent project I was working on had some pretty intricate parts in an engine bay. So I used the Space Spider and scanned the front engine cover, the timing cover. So I had all the accurate bolt holes and the geometry of the timing cover very well. And then I used the Leo to scan the complete engine with all the accessories and the engine bay with the reservoirs and hoses, and had those scans laid together. So I had the detail of the Space Spider to mount brackets and clips and hoses and the entire engine bay of a car, and was able to use that to model my entire assembly, which is around 180 parts. And yeah, most of the parts were 3D print, they fit. And we would machine one here in-house and that would fit. And it would have been a lot of work otherwise.
I've used all of the big name laser scanners in my past. 2 of these were based on articulating arms that stay affixed to a base. And I've also used a handheld laser scanner. They all had certain flaws as it related to what we needed to do.
I've been using 3D scanners for years now. We initially got into them to design complex parts that have to fit in engine bays, on car bodies, parts that would be difficult to design and without having a scanner. We also use them for quality control. When parts would come back in, we could check against the model.
So predominantly, we're using them for reverse engineering. We also are able to use the scanners for quality inspection. So for a lot of the parts that we design, if it's a very complex part that has somewhat of an organic shape, we will define a profile tolerance for the part that's impossible to measure with a set of calipers. So instead, we can scan the part and we can overlay that scan with our CAD model, and it'll tell us, our software will tell us how close that part is to the nominal shape. When we were shopping for scanners, the main thing that we wanted to find was something, particularly with the Leo, that could capture a large area in a quick amount of time, accurately enough for what we were trying to accomplish. And it solved all three of those things. Trimac has been easy to deal with. From our initial correspondence with Mike to support we've had afterwards, to email follow-up, to calls. Yeah, the process has been, I would say, painless and easy to follow.
I've called Trimac Tech Support a handful of times, and yeah, I usually get a response basically immediately, and yeah, everything has been great so far.